like before showing you two videos, which I did this work. I show you. And luckily, like Mr. Rahul, many points in my slides completed in the whole day. So I am very, this is a pleasure for me. Thanks. Now, it is okay. Then if you see, carbon comes in many forms, 3K to 50K. 3K is the finer and 50K is the coarser. So according to the application, we are choosing the carbon. Carbon roving goes in aircraft. Chopped carbon goes in infrastructure. Carbon fabric, carbon hybrids, and carbon sleeves goes in computer applications. And carbon tapes goes in marine and sport industry. Now, see, this is the certain carbon and this is the UD carbon. This both we made in Atira in 2013. This is the Jacob Muller machine of Switzerland. This is the Dornier machine of Germany. And this, I can go ahead, okay, because first. Now, these are the hybrids, cost effective. Suppose you see up to an stage, we need the carbon strength, then we require some like carbon and glass, both have the higher melting point. So we don't use the 100% carbon, it is very costly, this is almost 100 rupees kg. So we mix the glass, like that we mix the aramid. So these are hybrids. These are the nets. Nets comes in polyester also, nets come in glass also, and different applications there. And I'm a little bit fast, but please excuse me for that. There is a polypropylene and glass PPGL fabric. Then this what Rahul said, I just want to add something more. This project I did it with Nirma University during Atira. I made this carbon belts. You can just imagine a very big building having 10 to 15 floor standing on the pillars. Conventional pillar was the square type. Right now, pillars are the round type. So square type pillars are coming out on extremities and become weak. So before removing infrastructure to just destroy the infrastructure for construction, we can increase the life another 50 years by using this type of technology. I am not explaining the function actually. And the instant testing and everything was there. Then it is a better way in bridges. We are using the woven fabric and for heavy vehicles and high speed like bullet train, we are using the kneaded fabric with coating. Here we are using the solvent coating. Here we are using the lacquer. Then there is a certificate issued by Nirma University for this work. There is a remarkable increase in the strength. Then there is the lino fabric. We put the epoxy, taking the layers and using in the many places. Like we can use it in the marine also. We can use it in the aeronautics also. Many uses are there. This is made in Atira. Then this is a glass lino fabric. This is of 300 text glass yarn on Dornier machine again. It was made by us around 10,000 meters. In fact, during my tenure, we ran the Atira for 24 hours for developments. There are queue of the developments from the 365 customers there that time. So we are earning the revenue given to government. There was a position. Also, we started some courses for students, entrepreneurs, and professionals. Even online for NIFT and also still I'm doing actually. So people should have the advantage machine as well as technology is important. We should take the 100% output of the facilities. So this we are putting the tiles and everywhere. Suppose in Badrinath, Kedarnath, every time roads were slipping. If we put this type of things with the epoxy, roads will sustain for another 5 years, 10 years like this actually. Should I stop it and go on video or just give me time for 5 minutes? Okay. These are the aramid fabric and mostly goes for the armor. And this is the this glass fabric. If we are in a 3 width, here we are in a 33%, 66%, 99%, 100% achievement will take the of the machine. Then these are the 3D fabrics. These are the ropes. These are the belts with coating. So these are the, at very high temperature for rescue operations in firefighting. These belts are extensively used actually. These are the Jacob Muller machines of the Switzerland. These are the, actually, I don't not go in the depth, but core and sheath. Inside is the core, outside is the sheath. So stand comes the core. Suppose there is a one rope. It is made from carbon. But if you just use it, it is not aesthetic. So we are putting polyester to handle it like this for material handling. So stand comes from the core. These are the training for this parachute training. So when we are using the woven rope, they are having the only 30-degree lift. When we are using braiding rope, it is the 45-degree lift. Then we made for, I should not speak customer, but see, all these things we did for DRDO, ADRD, ISRO, Ahmedabad. They gave a lot of opportunity, NAL, Bangalore, Hyderabad, Indian Armor, all these companies we did actually. Then these are pultrusion. Many things we made actually. Lagos Airport, it is near my company. This ceiling is made from the pultrusion actually. It is evident. You can come and see. These are the nano mask. They are so effective. They can give the 99% filtration during Corona. They have been sold by Atira and developed to companies through companies, many, and their filtration for cigarette. They're giving one thing, so this directly nicotine not come on the this. So now developed a compressor by using braiding technology. Braiding, I show you the braid, but I'm just telling you, these are the braids. These are braided machine. It is in also Atira running. So these braids having the artificial intelligence also, they are using with this robotic technology. And these are also braids of aramid. Then these are the conventional fights in 1929 to 49, 20 years. They were running with a heavy load and just landing in the water, having no controls. Metal is there, metal was there. Now Dreamliners have come. And just I show you this thing. This portion of this fuselage is the hybrid carbon and glass. And so with the air stream, it will not worn out immediately. Then these portions having the Dynama. Dynama is the strongest fiber right now in the world. DSM Dynama is a company in Santa Cruz, Mumbai. Then the stabilizer keeps the plane, controls the direction. They also have the high class glass. Then some are with the aramid. Now, main jamming factor is that earlier all these things were importing from some from Japan, some from Spain, everything is there. But now Hansa is the aircraft which made indigenous by CSI, NAL and CSIR, Bangalore. Then Vikrant, INS Vikrant is a fighter plane. It is also indigenous. Then Tejas is also indigenous plane. So now Make in India policy, India is now making the planes with the own parts, not imported parts. This is good news actually. I will not go on that. Now, these are the preform for the bulletproofing. Actually, we got this biaxial fabric and did some coating of particular chemical. I cannot speak chemical and conventional clothes, but in forensic lab at Gayanagar, we tested this fabric. Six fire cannot go inside. But there's one request to everybody. Everybody knows right now social media is creating apprehensions and fake informations by some wrong videos. So one person is putting knife like this, they're boosting it. So customers are asking for the real, which is not possible. So please don't go cheating. अभी जो एक्सीडेंट हुआ था गिर पड़ा एक ऐसा वीडियो हो रहा था तो लोग उससे जहाँ डरने लगेंगे लेकिन ऐसा नहीं है वो कोई फॉल्स काम का गिर रहा था एआई से वो करके उन्होंने उसको वो कर दिया तो टेक्नोलॉजी के वजह से अनवांटेड एप्लीकेशन क्रिएट ना हो ये मेरा रिक्वेस्ट है Then you see the hybrid carbon and glass, cost effective. They're the fabric. are using for UV tents, ultraviolet tents actually. Suppose outside temperature is there, inside will remain 5-10 degree less because these tents. And if we see, there are 8 center of excellence in India under Ministry of Textiles and Center of Excellence for Asia. Dr. Singh is running this, organizing these programs. They are very informative. They are doing very well actually. And here I have given this presentation. So NITRA is for medical, ATIA is for composites, DKT for non-wovens. So any person wants to get the information or want to know something can go in the equation and get the things done. Thank you. Now we go in video. कहाँ से करना है video? This is the carbon weaving actually. 3K carbon. The carbon is very costly. So we are making the small cone, big cone, small cone. Even front side we are putting polyester. So waste will go in the polyester. And only fabric will remain with the carbon. This is a Dornier weaving machine. So this carbon is made for particular use of industry. So this carbon weaving. Then I show you the braiding. Next video, please. This one is the braiding actually. Here you see this glass yarn is there. One is running in clockwise direction, other is anti-clockwise direction. They are making the braid. These braids are being used for the asymmetrical and symmetrical braids for defense, for ISRO, for inflatable antenna, aircrafts, all this actually. Lot of scope of this machine actually. It is in Atira. One can go and see. So this is a braiding machine. Depends. Sometimes they are running carbon, sometimes they are running glass according to order. DRDOs, ISRO, all are working on this actually. This machine is of Germany. There are some 3-4 countries giving the braiding machine actually. Thank you, Raj. Any question you can ask? Sorry for very fast.
No, it is good. Appreciate it. Thank you, Pradeep ji, for your presentation and use of textile, typically technical textile, to be used in composites and other good applications. Thank you very much for your presentation, and I would request Dr. Saab to please felicitate him.